Question 1 starts with a ball with mass m moving 4 meters per second collides with another ball with mass m that's at rest. After the collision, we have our first ball going off at 30 degrees with some speed, and our second ball going off at 60 degrees with some speed. The question is, we want to find what are these final speeds going to be. So, whenever you see collisions, think momentum. Okay. So in any collision, momentum is always conserved. So we write momentum with a P. So we say the initial momentum is equal to the final momentum. Now what is momentum? Momentum is mass times velocity. So since there's two objects, each will have a momentum, and we'll determine which ones are zero and which ones are not zero. So we have m1 v1 plus m2 v2. These are all our initial. It's got to be equal to m1 v1 plus m2 v2 final. Now momentum is a vector, so we also have to make sure that these have directions. With any two-dimensional problem we do, what I mean by two-dimensional, it has both a y direction and an x direction. We want to split any of our vectors into both the x and the y directions. So let's look at just our x direction to start with. We have momentum is going to be conserved in both the x and the y directions. So we can say the momentum initial in the x direction is equal to the momentum final in the x direction. Or m1 v1 plus m2 v2 initial in the x direction is equal to m1 v1 plus m2 v2 final in the x direction. So now we have to go back to our problem and look and see what's in the x direction and what's in the y direction. Well, initially, mass 1 is moving only in the x direction. M2 is at rest. Finally, M1 is moving in both the x and the y direction, and M2 is moving in both x and the y direction. So let's look at our first mass and try to break it up into both its x and y parts. Okay, so to break anything up in its x and y parts, we need sine and cos. So, Let's try sine. Well, let's start with cos. Cos 30 degrees, we're looking at all one, is equal to adjacent. My adjacent side is going to be the x direction. So it's v1x all over the hypotenuse. Well, the length of this side is v1. It's the total speed. So if we get v1x all by itself, it's v1 cos 30 degrees. Now you can try the same with sine, and you'll see v1y, v1 sine 30 degrees. We can do the same thing with the second mass. We're going to get v2x, this x part, we're now using the angle 60 degrees, so it's going to be v2 cos 60 degrees. And in the y direction, it's sine. Now we have to be careful when we're looking at this, because when we plug this into our values, notice what we said the positive y direction is. So this is going to have a positive y direction, meaning v1 sine 30 is going to be positive. Here, negative y direction. So we're actually going to have to put a negative in front of it. Okay. Looking back at what we wrote, we want to note just the initial velocities in the x direction. So here, mass 1 is moving in just the x direction. So I can say m times 4 meters per second plus the velocity of m2 is 0. So 0 times any number just gives me 0 again. So that's our initial. And our final velocities in the x direction, we have both this and this. Now look, they're both in the positive direction. So I'm going to have positive v2 cos theta and positive v1 cos theta. M, v1 is going to be v1 cos 30 degrees. M, v2 cos 60 degrees. Okay, now notice if you divide both sides by m, we have m divided by m, 0 divided by m is still 0. These m's cancel, so we're just left with 4 is equal to v1 cos 30 degrees plus v2 cos 60 degrees. Alright, this is our first equation that we're going to use. Now notice, we can't get v1 or v2 is equal to some number. v1 is always going to be in terms of v2 in this equation. So we need another equation. If you have two unknowns, you need two equations. So our second equation is going to come from the y direction. We've done x direction, let's do y direction. To save some time here, I'm not going to write this. I'm not going to write this. The only difference is this is going to be changed to a y. This is going to be changed to a y. So you should write that down yourself. Pause the video if you need to. In the y direction we have, initially, let's look. This has no y component. It's only in the x direction. So its y component is 0. This one's at rest, so it has no y component either. So on the left side of our equation, we would have 0, 0, 0 is equal to. On the right side of the equation, we do have values. Let's look back here. We have this component and we have this component, our two y components. Now, notice, this y component is positive. This y component is negative. So our positive component is going to be this one. M V1 cos 30 degrees. I'm getting that from here. I apologize. Y component is sine. In the other y direction, the other component, we have negative. It's going down. It's going down. So we have negative M V2 sine 60 degrees. Again, divide both sides by M. 0 divided by M is still 0. So I'm going to bring this on the other side now. I have V2 sine 60 degrees is equal to V1 sine 30 degrees. So let's get one of these. Here's our plan. We're going to get one of these all by itself. So just say let's get V2 all by itself. So divide both sides by sine 60. Then we can take all of that and sub it into our first equation for V2. All I did was divide both sides by sine 60. And if you use a calculator, you'll see this is V1 sine 30 divided by sine 60 times 0.577. I'm going to call this equation 2. So now what we're going to do is sub 2 into 1 and solve. Four is equal to V1 cos 30 degrees plus V2. Apologize, that's what we're subbing in. We're subbing in our V2. So for V2, we're going to put V1 times 0.577. And our last term, that was V2. Now we have cos 60 degrees. I'm not going to have time to finish this. I'm at the 15-minute max for YouTube. So if you need help with the algebra, please come in.